In the astonishing ascent of artificial intelligence, large language models stand as towering achievements, capable of generating human-like text with uncanny fluency. They write poetry, code software, and answer complex questions, often with remarkable accuracy. Yet, woven into this tapestry of capability is a peculiar flaw: the phenomenon of hallucination. An LLM might confidently present a detailed, authoritative answer that is entirely, demonstrably false. This isn't a bug in the traditional sense, nor is it a deliberate deception. It's a fundamental characteristic of how these powerful systems operate, and understanding it is crucial to navigating our AI-driven future. So, what exactly is an AI hallucination? Unlike a human lie, which implies intent to deceive, LLMs don't possess consciousness or malice. When an LLM hallucinates, it fabricates information that sounds coherent and contextually appropriate but is factually incorrect, nonsensical, or contradicts its own provided source material. This can range from inventing non-existent books and authors, to misstating historical facts, or creating entirely false scientific data. It's the AI's most sophisticated form of making things up, rooted in its statistical nature rather than any understanding of truth. The primary reason LLMs hallucinate lies in their fundamental design: they are statistical prediction engines, not knowledge repositories. Trained on colossal amounts of text data, these models learn intricate patterns, grammatical structures, and semantic relationships between words. When given a prompt, an LLM doesn't think or understand in a human sense. It calculates the most statistically probable sequence of words to follow, based on the patterns it observed during training. It's an advanced form of autocomplete, constantly striving to generate the most sensible next token, regardless of its factual accuracy in the real world. The vast datasets LLMs are trained on, often comprising a significant portion of the internet, are a double-edged sword. While they provide the breadth necessary for impressive language generation, they are also inherently noisy, inconsistent, and replete with biases and misinformation. LLMs absorb these imperfections. If certain false statements appear frequently enough, or if the model struggles to differentiate authoritative sources from unreliable ones, it can internalize and reproduce these errors. The model isn't discerning truth, it's replicating patterns, even flawed ones, from its colossal training corpus. Another critical factor is the LLM's inability to know when it doesn't know. Unlike humans who can admit ignorance, LLMs are designed to always provide a coherent response. When faced with a query outside its training data, or one that requires deep reasoning it doesn't possess, an LLM doesn't stop or say "I don't know." Instead, it defaults to what it has learned to do best: generate the most statistically probable sequence of words that sounds like an answer. This process, often termed confabulation, leads to the fabrication of details to fill knowledge gaps, creating convincing but entirely invented realities. The generation of text by an LLM involves a complex decoding process where the model iteratively selects the next word. A crucial parameter in this process is temperature. A lower temperature setting encourages the model to choose highly probable, more deterministic words, resulting in safer, more factual but less creative outputs. Conversely, a higher temperature allows for more randomness and exploration, leading to creative and diverse text but also increasing the likelihood of hallucination. Balancing precision and creativity is an ongoing challenge, as the very mechanisms that allow for engaging prose can also introduce errors. Another contributing factor to LLM inaccuracies is the knowledge cutoff date. While LLMs are trained on massive datasets, these datasets are static snapshots of information up to a certain point in time. They are not constantly browsing the real-time internet. Consequently, an LLM cannot access information or events that occurred after its last training update. Asking about recent news, current figures, or very new developments will often result in hallucinations, as the model attempts to generate a plausible answer based on its outdated knowledge, rather than admitting it lacks the current data. Recognizing the inherent challenges, AI researchers are developing sophisticated strategies to mitigate hallucination. One of the most promising is retrieval augmented generation, or RAG. Instead of relying solely on its internal, potentially outdated or flawed parameters, an LLM equipped with RAG first queries a trusted external knowledge base or database. It retrieves relevant, verified information, and then uses the retrieved context to generate its answer. This approach effectively grounds the LLM's response in real-world facts, significantly reducing the likelihood of confabulation and improving factual accuracy. Beyond RAG, other mitigation efforts are crucial. Fine-tuning models on highly curated, factual datasets can improve their reliability for specific tasks. Sophisticated prompt engineering, carefully crafting instructions to guide the LLM, can direct it towards more factual responses and away from speculative ones. Human oversight remains indispensable, particularly for high-stakes applications, with humans reviewing and correcting AI outputs. Furthermore, ongoing research into new model architectures and training methodologies aims to embed a deeper understanding of truth and factuality into the very core of LLMs, making them inherently less prone to hallucination. Despite these advancements, hallucination is not a problem that can be entirely solved in the same way a software bug can be patched. It's an inherent challenge of models designed to predict text statistically, rather than to comprehend or reason about the world. As LLMs become more complex and their training data grows ever vaster, the potential for novel forms of hallucination may even emerge. It's an enduring puzzle at the forefront of AI research, requiring continuous innovation, vigilance, and a nuanced understanding of these powerful yet fundamentally non-human intelligences. The quest for truly grounded AI continues. The phenomenon of LLM hallucination reminds us of the dual nature of artificial intelligence: immense power coupled with profound limitations. As these tools become more integrated into our lives, a critical understanding of their strengths and weaknesses is paramount. For developers, it means pushing the boundaries of accuracy and robustness. For users, it means exercising critical thinking, verifying information, and recognizing that even the most convincing AI output may not always be true. By acknowledging and addressing hallucination, we can better harness the transformative potential of LLMs, fostering a future where AI is not just intelligent, but also reliable.